Good afternoon, ladies and gentlemen, and welcome back. The 10th and final session of the day is titled Hydrogen, the Next Clean Energy. And the topics include developing a hydrogen economy system, cost comparison with other ecosystems, providing government grants for R&D, and a lot of other important points. And I would like to now introduce our esteemed panelists for the session. My pleasure to invite Dr. R.K. Malhotra, Director General, Federation of Indian Petroleum Industry. With more than 32 years of experience in the energy sector, Dr. Malhotra is a veteran and well-known personality in the sector. He's a member of several important national committees and also the founder, president of Hydrogen Association of India. We also have with us Mr. Vidya Sharma, Managing Director, Jindal Steel and Power Limited. Mr. Sharma is a leading technocrat with more than 37 years of experience in steel, power, cement, and mining industry. During his tenure, JSPL has shown excellent performance on all fronts, including an impressive high production and sales turnover during challenging COVID-19 pandemic. I'd also like to welcome Mr. Sturle Harald Pedersen, Chairman Greenstat Hydrogen India. Mr. Pedersen is an experienced CEO with more than 30 years of global experience in leading successful business initiatives. He has an extensive experience of initiating and leading international alliances with strong emphasis on accelerating the transition from fossil fuels to renewable energy. We have today among us Mr. DMR Panda, GM Hydrogen NTPC Limited, with over 31 years of extensive experience across various functions. Mr. DMR Panda has been associated with NTPC Limited since 1990. Dr. Panda is ASQ Six Sigma Black Belt certified and instructional designer for training and learning interventions. It's also my pleasure to welcome Mr. Anurag Pandey, team lead, Reliance Industries Limited. Mr. Pandey leads strategy and technology activities in hydrogen economy at RIL. For the last 9 to 10 years, he has been ardently working on clean energy solutions, particularly fuel cell technology and hydrogen economy. Next, I would like to introduce Mr. Jitendra Goyal, General Manager R&D, Toyota Kirloskar Motor India. With more than 25 years of experience, mainly in automobile field, Mr. Goyal is leading from Toyota to introduce future technologies, introduction and setting up XCV ecosystem in India. We also have with us Dr. Klaus Brun, Director R&D Elliott Group. Dr. Brun leads a group of over 60 professionals in the development of turbo machinery and related systems for the energy industry. It's also my pleasure to introduce Mr. Amrit Singh, Senior Managing Director, FTI Consulting, who will be moderating this session. Mr. Amrit has over 20 years of experience in advising global clients on policy, advocacy, global geopolitical risk and strategy communications with a focus on India and South Asia. Over to you, Amrit, for setting the tone and discussion of this particular discussion. And Mr. Praveen Prashant has also joined us.
Thank you very much, Rahul. And firstly, I welcome all the panelists to this very, very important discussion today. And if I do drop off, I will log in from a mobile device, but I think the connection is good. I'm actually traveling.
And Amrit, don't worry. I being a co-moderator will help you out in case you drop. So don't worry, I'm there. And many thanks to Mr. VR Sharma. Despite being jet lagged and out of country, he joined us. I don't know which location he is. So many thanks to him. And many thanks to all our panelists who have joined us.
Good afternoon to everyone. Thank you so much.
Thank you, Mr. Sharma. And so, without much ado, why don't we jump in? I think introductions have been done, but I will just summarize a little bit discussions that have taken place with different stakeholders, government, industry, international stakeholders as well, around the necessary steps that are required to create a hydrogen economy in the country. And the esteemed panelists here have been part of some of those discussions. But really, what do we want to achieve today? Beyond the discussions that we've all had, separately or together in different fora, the idea would be to move forward and talk about what is really the next steps that are required to create the hydrogen economy. I think I would urge all the panelists to look at this discussion from that perspective. The transition to a hydrogen economy, or the wider transition to the energy transition, is a difficult and complex process, and will probably happen through different phases. But I think all the stakeholders agree that this is such a complex transition that it requires all stakeholders to work together. So if there's one common theme, it is that this needs collaboration between industry, government, and of course investors for an economy that will probably mainstream in about 10 years from now. But it's the critical steps that we need to take in the next 12 to 18 months, which will define whether the commercialization of hydrogen is accelerated in even next 3 to 4 years, or is it not? One point that I would like to make is, we all know that this discussion is not new. India had a hydrogen policy more than 10 years back, but we haven't progressed on that, and the onus for that probably lies on multiple factors. It's not just about implementation of the plan that was put in place. The technology has changed. There have been developments, and we see internationally there is a lot of progress towards hydrogen as a fuel and as an energy source, not just for transport, but also for industrial use. The funding ecosystem has matured today. Today you have entirely privately funded, listed companies commercializing hydrogen. So let me stop there, because I don't want to take away from the discussion we're going to have. But what is very, very helpful is the sort of the breadth of experience we have among the panelists. What I would like to do is to go around the panelists and ask them, what do they think are the, firstly, please feel free to make opening comments. But if you could answer 3 questions or 3 points where you'd like to see progress in the next 12 to 18 months. Now, these could be, these should not be only from your, let's say, existing enterprise side, but really from the ecosystem side. What would you like to see? Whether it's from the policy side, investor side, or within your industry. So with that, can I ask Sturle to kick off? There has been a lot of discussion about the collaboration between India and the Norwegian companies. Norway has been at the forefront of commercializing hydrogen. So please, Sturle, give us a perspective from there, and then we will move around the group. Thank you very much.
Amrit, just an important announcement that Anurag Pandey, team lead Reliance Industries, he is in an urgent meeting, so he will join late. So whenever he joins, I will let you know. And please check your WhatsApp message also at the same time. Thank you.
Sturle, please.
Thank you. Yes, it's quite a challenge for not only India, but for the world to find the right way forward to make sure that we are moving with the necessary speed and force to implement the hydrogen ecosystem. But I think that the government is instrumental in starting this and to set the framework for the industry and for all stakeholders to be working efficiently. So I hope that, and I also believe that the Indian government will implement good guidelines, policies, regulations and standards that is uniform in India, but also harmonized with the rest of the world. And it is clear that in safety, for instance, there is 2 ways to go about it. One is the descriptive policies, which would take years to develop, and it is not possible to do it if we want to speed up this transition. So it has to be functional, the way to develop the policies. So that is what the government has to do. And the government can do this by themselves. You pointed out that international collaboration is important. Norway has been offering the support and help in this area. There has been developing policies for many years. But we also need to bring along other partners in the States, so in EU and Australia and other places where they also have developed standards and policies to align them all together. So I think that would be the priority for the government and for bringing this transition up to speed. The framework must be in place. Then the investors, the banks, the financing institutions and so forth that need to fund this would be coming along as well. We see that in Norway, there is several institutions now that is setting aside funding for this transition. But we also see that the banking and the financial institutions are giving green interest rates, which is lower, and actually punishing the fossil companies by higher interest rates. So this is a way of trying to give the incentive, but also give the push to the fossil industry to take part in this transition as well.
Thank you, Sturle. You touched upon a very, very important part, and thank you for that, to talk about the importance of carbon markets, which is well developed in EU and other parts of the developed world. I think there's a unanimity of views that without carbon markets and carbon pricing, and at least an accurate assessment of carbon pricing, the energy transition cannot happen, or even if it will happen, it is based at best on good intentions, not on economic ones. So we will come back to this. Thank you for introducing that element, Sturle. And one day I ask Dr. Brun, Dr. Klaus Brun, if you can come on. I see he's finishing a call, so maybe we can invite in Mr. Malhotra to come in. Dr. Malhotra, sorry. So what is your view? Because again, you represent a large group of companies, including natural gas players. What is your view from the, I wouldn't say incumbent side, but people who have the have a view of how this transition should take place? Can we accelerate it? And would you agree that the importance of carbon markets are important?
Well, thanks, Amrit. You very rightly said that we have been talking about hydrogen, for last 10 years or so. When we started discussions, there was a committee at one point of time made under the chairmanship of Rattan and Anand Mahendra. I think that was about 14, 15 years ago. World over also, we know that hydrogen is the cleanest fuel, is the most abundant element on earth, and but how to get it, that's in the usable form, in economical price, that is the major question. So having said that, this why it has started now, all this discussion is all because of this, in the pandemic, people realized that whether this climate change, which is happening, is causing a lot of floods and cyclones and so many things, but is this pandemic also followed? I don't know really. Is a health issues also that the climate change could be accelerating the problems of that kind. And we got used to clean skies somehow, during this lockdowns which we saw. And we realized that there is a, possibility and perhaps we can come down with carbon. We can reduce and we can have reduce carbon in the air or emissions or pollutants in the air, and then we can breathe the fresh air. So having said that, India is a country, I'll be talking about India specific. We are a fast growing economy, and we will continue to grow. The aspirations of our middle class will grow. So what is required in India is energy while having and meeting the climate commitments. So this is the job which we'll have to do, which is not that difficult for other countries because they have to meet only the climate commitments. The energy demand is stagnant or will come down with more efficiency, etc. But in India, we'll have to do both to meet the climate commitments as well as meet the aspirations of people in terms of per capita demand, which is bound to grow with the growth in economy. So having said that, and agreeing that hydrogen is the cleanest fuel, the issue is where it will come from. How do we get it in a usable form and at what price? You know, in an economy like ours, which is growing, you can't be having a very expensive hydrogen pumped into the market and tell people, okay, you use this only and nothing else. This is the source which is at whatever price you have to pay, then the economy is bound to suffer. So we'll have to have a balanced approach. While we, people keep on talking that some of the policymakers also in the country have been saying that we should be going to green hydrogen alone. We have large reserves of coal. We are producing a lot of electricity from coal. And we have Mr. Panda from NTPC, and I'm sure the NTPC will continue to produce coal-based power for at least 1 or 2 decades in the country. I don't know the plans, but that's my belief is that does it make sense that we continue to use coal for in thermal power stations? We may shut down them slowly, but we are certainly going to use them for next decade or so. And while we use renewable power to produce hydrogen, can't we replace that? So we will have to prioritize and see that how the overall carbon emissions from this country can go down. Now, another issue which needs to be possibly seen is that, whether we can gasify coal and, near the coal mines, put that CO2 underground and use that syngas and then produce hydrogen. And then sequestration will have to go along with carbon sequestration, along with our conversion to chemicals, etc., will have to go along. So while large reserves of coal in India cannot be allowed to go waste. We are an energy, importing country. So we'll have to see that. Certainly renewables are growing. I wish they will grow, wish they grow even faster. But whether in next 15 years, 10 years, we will be able to have sufficient renewable energy to cater to all our demands that we shut down our thermal power plants based on coal, whether we'll have sufficient, electricity that we meet all our electricity needs, and we also produce hydrogen and use only green hydrogen. These are the issues which we need to see and debate and find the right solution, whether we can use blue hydrogen side by side, because we wish to go to green hydrogen and that will be the ultimate, but the route has to go through gray, brown or blue, particularly blue, and then and the green hydrogen. Because if you wait for green hydrogen to be available in sufficient quantities and also at affordable price, because affordability in our country and for our economy is equally important. If you wait for that, to build up the infrastructure, the users to accept it, I think we'll miss the bus. So I personally feel that we need to continue to work, because infrastructure building for hydrogen will take time. And we will also, making our industry to accept green hydrogen as a fuel, that transition will take time. So meanwhile, we should build up the infrastructure, whether we use blue hydrogen or to some extent even gray hydrogen, it doesn't matter. Ultimately, we'll reach green, but the route has to go through this. If we say, no, we'll use only green, I think we'll be just, living in a thinking that we'll do that and we'll not be able to achieve anything on hydrogen side. And on regulations, I agree with Mr. Sturle fully that we do not need to reinvent the wheel. we can adopt the best of the standards globally, best of the practices, and the government will have to ensure that I know Mr. Jitendra Goyal is here, and I personally know that how much Toyota has been struggling to get the clearance for their hydrogen fuel cell car from PASO. Those things should be streamlined. And whatever, if a car can be used in California or in Japan, why that same car cannot run in India, and why should we go through the process of, again, fresh regulations around safety? So these things I think we'll have to address. But I personally believe that we'll have to, accelerate the infrastructure building, which will storage, transportation, because the storage and transportation cost at points of time is more than the cost of production of hydrogen. So we can't be waiting for $1 hydrogen to be, or $2 per kg hydrogen to be made available to our industry, and say that, okay, we'll use that only, and currently $6 or $8 per kg of green hydrogen is not affordable, so nothing will happen. So that's my view.
Thank you, Dr. Malhotra, for that pragmatic view. You mentioned about the need for a roadmap, because it's important to see how the various pieces to start to move together. And demand creation is going to be critical for that, because you can't plan scale unless we have some assessment of what demand will be like 3 years, 5 years, 10 years down the line. So before we get into the demand discussion, and we are fortunate to have the views from both the transport side as well as the industrial side on this panel, I just want to cover off from Mr. Brun, Dr. Klaus Brun. What's your view from a not just an R&D perspective? I know you're sort of heading R&D for the Elliott Group, but how do you see the switch from moving beyond what would be small proof of concept to commercialization? I mean, you've done this in different parts of the world. And more importantly, Klaus, how long does it take to make that transition? Because it's not something that you would achieve in 6 months.
And Amrit, just adding to what you said, the question would be, where is the market going? And Dr. R.K. Malhotra also talked about different flavors of hydrogen. So he would be in a better position to talk about green versus blue hydrogen and what are the optimal schemes to deliver hydrogen. So Dr. Klaus Brun.
Yeah, I guess I hope you can hear me. And I guess similar to the previous panelist, a couple of quick comments regarding green versus blue hydrogen. And this may be a US-centric kind of view, but from what we're seeing over here is that green hydrogen is, at least in the near term, somewhat of a pipe dream, in that it is not anywhere near cost effective. From either a production perspective, even at free electricity, even if absolutely no cost is associated with electric from alternative energy sources, even then, if you do a basic calculation of green hydrogen, you end up with a price that's somewhere around 2 or 3 times as much as the most expensive blue hydrogen, including all the costs associated with sequestration. So there is a significant cost impact with green hydrogen. And then the other argument with green hydrogen that is misleading is you can look at green hydrogen really just as a storage medium, right? Because it doesn't have a tremendous amount of value if you look at it as a transportation medium, because you may as well send your electric down a transmission line. So if you look at it from a storage perspective, then you always have to look at its round-trip efficiency. And from a very basic round-trip efficiency perspective, making green hydrogen is going to cost you about 15 to 20% of the energy. And then you need some kind of heat engine or a fuel cell or something like that to convert your green hydrogen back to electricity at wherever you want to use the electricity, which is going to cost you another between 40 to 50% of your energy. So your overall round-trip efficiency of green hydrogen from a storage perspective is incredibly low. Right? It's somewhere in the 40%, which doesn't compete with any other storage technology that's already either being developed already commercially available, such as compressed air energy storage or other things. However, we do think that hydrogen has a significant role to play from a perspective of blue hydrogen, in that blue hydrogen is a transition technology that gets you from a fossilized supply of energy to a green supply of energy in the future, maybe 20 years, 30 years from now. And blue hydrogen does provide the potential of essentially being carbon sequestered and being carbon free, if done correctly with all the leakage avoidance and CO2 emissions avoidance. So we see blue hydrogen as a significant potential. Now, one of the things that is important to understand is, where do you get hydrogen and where is it, how is it transported? And there's really several theories out there. One is, okay, you get your natural gas out of the ground and then you run through a steam reformer or whatever, partial oxidation reaction, and then you take your blue hydrogen to wherever you need it. That requires a significant pipeline infrastructure, hydrogen pipeline infrastructure. And hydrogen is a pain in the neck. Hydrogen is a real difficult gas to transport. It's a light gas, difficult to compress. It's not a very safe gas. It causes hydrogen embrittlement. It leaks all over the place because it has small molecules. So it's not a really good gas to transport. On the other hand, I mean, you can very easily make the argument, you may as well use the existing pipeline infrastructure that you have, natural gas infrastructure, transport your natural gas to wherever you want your hydrogen, and then as close as possible to your end user site, most likely a power plant, industrial complex, or whatever, and that's where you produce your hydrogen. That leaves you then with a need to transport your CO2 somewhere. You've got to take the CO2, put it into some kind of geological formation to sequester it. And that's a different challenge, but that's a manageable challenge, whereas hydrogen transportation is not an easy challenge. CO2 transportation is relatively manageable. It's not a cheap challenge, but it's a manageable challenge. So we actually see, when we're talking about from a manufacturer perspective and a compressor vendor perspective, when we're talking about hydrogen economy, we're actually seeing far more need for CO2 compression and CO2 transport than actually hydrogen compression and hydrogen transport. Because most likely you're going to make your hydrogen as close as possible to your power plant. You're just going to put in a fuel gas compressor for the hydrogen, and then you have to worry about your CO2. So that's maybe somewhat of a centric perspective, but that's kind of what we're seeing over here.
Thanks.
That's the question.
Yeah. Thanks, Dr. Brun. You talked about, I mean, or rather you qualified a very important discussion that's happening about blue and green, and Mr. Malhotra talked about that. There's, of course, pink as well, and turquoise, right? So different forms, nuclear energy is going to be important for India. But again, the colors of the different forms of hydrogen, I think there's a sort of consensus that they are important, at least among the technologists, right, as to what will be feasible in the short term, medium term. But I think rather than it become a point of contention, have everybody choose which color of hydrogen will be important in the short term. I think it's also important to talk about the other infrastructure problems you pointed out. Storage, transport. Today, we don't have any standards, whether it's blue, green, pink, whatever you want to call it, the hydrogen, how do you transport it? We don't have a common way of planning for development scale commercial projects, because, there is no one authority which will give you end-to-end the supply chain sort of sign-offs or approvals to put a plant and have it used. So my point is, we can discuss, what is the right sort of sequence of blue, green, pink, or we can focus energies on the other equally important parts of this challenge, which is, let's plan for the supply chain. Let's talk about standards and safety, because again, these are points which will take at least 5 to 7 years for maturity to set in before we can move hydrogen safely to points of use. Today, we don't have that ecosystem to allow that to happen, even if we were to choose, let's say, it's green or blue or a combination of both. So with that, I would like to sort of move towards the demand side of the discussion. And if I can ask, Mr. Jitendra Goyal, Toyota has been the forefront of this, of course, in Japan, but also in India. And so let's cover the transport use case and how you see Toyota's view on this, and not just Toyota's view. Please speak on behalf of also the transport side of hydrogen. I'm also aware that you have mobile fuel cell applications portfolio as well. So please cover that too. Not everybody would be aware of Toyota's portfolio there. So please cover stationary fuel cells view as well, please.
Sure. Thank you, Amrit. So regarding as far as the hydrogen, if we see from the demand side, from the technology side. So from the technology side, I think a lot of things has happened. Last 2 decades, we are working in the technology. And as far as fuel cell stack technology is considered, it is quite mature now. As you know that there are the commercial application has started globally. Now we have launched in last year Mirai Generation 2, which is quite a mature technology, and a lot of improvement has happened, not only from the technology point of view, in the cost point of view, making it compact, making it more efficient. Like currently, Mirai Gen 2, it can run more than 1,000 kilometers in one charge. So that point of view, I think technology point of view, it is ready to do the application. And not only in the mobility area, same fuel cell stack, even we have applied for buses. And as you would have heard that in Europe, we are running the buses with the fuel cell stack. And even we have started applying it for the long haul trucks in different countries like US and Japan. Already we have started the project for trucks, and including even for ship, train, various applications based on the requirement, we are applying the fuel cell stack. So from that point of view, technology is in place. And as you told, from the stationary point of view, the same fuel cell stack now we have announced in February 21 by globally that we have prepared FC module, fuel cell module, which is plug and play kind. Anybody can buy it for either stationary application or can buy it for the mobile application. So even a stationary genset, like for the servers and all, we need 1 megawatt genset. By using the multiple unit, we can utilize that FC module and we can place the digital genset there. So from that point of view, we are ready with the technology, and we are discussing with various partners globally to utilize this technology and implement it. Now, what is the challenge? Challenges are mainly, we know that, as you also talked, that it is coming from the economic viability, how we can do the commercialization. So for doing the commercialization, what is our view and how to achieve the commercialization? The first most important point is the scale. If we don't have the scale, whatever is the mature technology, the production can reduce the cost only by achieving the scale. And how to achieve scale is by using the wider uses. Only one kind of uses cannot reduce the cost of either hydrogen production or not for the fuel cell stack. So if this technology, we use it as widely, we need to use it for mobility, either truck, buses, a train and everything. We need to use it for genset. We need to use it for power plant. We need to use for steel plant. So as much as we do the wider uses, that much will go up and cost will come down. So that's why, as you told in starting, that collaboration is key to make hydrogen economy viable. Second point comes is the how to start this wheel. Currently, this wheel is not started rotating. The main reason is, as Dr. Malhotra was also telling, even though we have got the technology, we have got vehicle in India, but still we don't have a single commercial fuel dispensing station in India. So we can't start using this technology even for the pilot project. So we need to start somewhere. So for that, yes, a lot of initiatives are happening, but something on ground is required. And we need to have the fund, we need to have the infra setup, that is very, very key, at least to have the experience of the technology. So we need to, like you would have seen that in China and many other countries, Japan and US, lot of big pilot projects has started in the confined areas. That may be the start point, but we have to start somewhere. That is very, very important. Then third point is we need to, regarding the policy and regulations, of course, as mentioned, that it is very important that we don't reinvent the wheel, either from the technology point of view or regulation and policy point of view. The most important thing is how we can make technology cost competitive in India, and for that localization is key. So I think if we adopt the global technology as it is, but we do the make in India kind of, like first we can start with the smaller parts or with the easier parts, and then we can go to the FC step. Then we can make the technology more easily adaptable in India. So I think these are the starting steps. And as you told, next 12 months to 18 months is very, very critical to make clear the roadmap. Most of the developed countries are clear how many fuel stations by when, the cost target, and what will be the, everything means that kind of roadmap is clear. So how many fuel stations by when we are going to have in India, better we have that kind of target. That clarity only can motivate the OEMs and everybody to invest and everybody to come together to bring this hydrogen economy. So I hope that in 12 to 18 months as announced, we will be clear where do we see in 2030 ourselves. How many fuel stations, how many buses, how many trucks, how many genset, what is the target and how we are moving in that direction. So that is what the expectation is. So that is my starting. Thank you.
Thank you, Mr. Goyal. The reality is we had a beautiful set of targets in the previous hydrogen policy as well. And again, this is the advantage of being a consultant. You know, you can speak things that maybe incumbents or stakeholders will be not comfortable talking about. But we also need to spend some time to think about why we haven't hit any of those targets, right? I mean, I know we have 1 or 2 refueling stations. Some of them probably need to be, taken to the next level in terms of technology appropriateness. But because if we don't learn from that process, or as I would say, the learning from the last 10 years and apply it to the next 10 years, we will pretty much be at the same place. So from the transport side, and again, we don't need to spend more time right now, but we would like to come back, Mr. Goyal, on this. If as Toyota, one of the foremost companies, you're saying all of this is possible, we can localize, technology-wise, the technical challenges have been met, or they can be met. It's really an economic discussion. Would really sort of like to progress on that point. If I hear correctly, that's what you're saying we need to focus on in the next 12 to 18 months. So, Mr. Panda, if you're on, would like you to come in because you are taking that step forward, pioneering step on moving forward with the FC buses. So, would you want to share your perspective? What are some of the challenges, or where do you see, even beyond, talking on behalf of the transport use case side, beyond just NTPC as well, where do you think from an ecosystem standpoint more can be done so that the commercialization happens faster? Over to you.
Yeah. Yes. Thank you so much. I'll just tell my personal viewpoint or my organizational point of view. One, the same thing. Why do I say? Because I mean, this is being discussed again and again. Now, ultimately, why you are doing all this for hydrogen? Now, one is that India doesn't have enough resources for petroleum products. We import them at a great cost, number one. We have abundance of land, wind, solar. This is one aspect. The other aspect is that we need to decarbonize. Now, whenever they talk around decarbonization and all that things happen, everybody starts speculating. And this is not a new thing. I'll just go back, say, 200 or 300 years back. Now, when internal combustion engine started, people started replacing horse carriages, or when steam engine came. that there are similar kind of discussion. It is good. Is it not good? Is it not costly? But ultimately, the time will tell what is successful, what is not successful. And being in electricity industry, being an engineer myself, I just very tempted to quote one example. When alternating current and direct current started, now when electricity was invented, so people started discussing whether AC is good or DC is good. Now, after almost 100 years, again that debate has started. Probably direct current electricity is better than alternating current. So my point is that only time would say whether we are on the right track or not. But rather than discussing, we should start doing something which, to our best of knowledge, is good enough. Having said that, now what is that big organizations can do? Why I say big organization? Because they have somewhat deeper pockets. They can absorb certain kind of risk and then start doing something. And I really compliment NTPC, not because NTPC is my employer, but so in the same breath, I'll say NTPC, IOCL, or different organizations in India who are trying to do something on the hydrogen front, only to see if it makes sense. If it makes sense for the public, if it makes sense for the climate, and climate is very important because say iPhone. Now, iPhone are costly, but still people are going for iPhones. But in case of hydrogen, because it is costly, because it is inconvenient, should somebody be resisting from using it? Now, there comes the role of the government. So what common citizen cannot see, probably the government can foresee, the government can plan what is for the better good and do something. So having said all this, the next point is that we must try to do something which, to my common understanding, which to my present understanding is good enough, which is the green hydrogen. And once I start doing something, probably I'm on the right track. Does it make sense or not? And then I can revisit my course of action. In any case, we all are in a very exciting time because multiple things are happening. Green hydrogen has come, which people are saying that this is like elixir. Until now, we are not having any antidote for this climate problem. Now that at least we have something to try. And that is what the viewpoint of NTPC is. That's it. Thank you.
Thank you, Mr. Panda. Also, what you have also very nicely put forward is the importance of going and at least doing commercial scale projects. And as we have seen from the developed markets, whether it's funding or even more supportive actions from government or other parts of industry, will not happen if there are no development stage projects.
True.
I mean, we have heard this from the funding agencies, the multilateral agencies. They have gone to the extent of saying funding is available, but if you don't have a pipeline of projects, money can't come in. So it's a bit of a chicken and egg.
Yes.
And so thank you for sort of mentioning the importance of a pipeline of large projects. Mr. Sharma, if you can come in and talk about the steel sector particularly, and the role for hydrogen to decarbonize the steel sector, because it's being seen as possibly one of the foremost sectors where hydrogen commercialization could be introduced very quickly in the shorter term. Over to you, Mr. Sharma.
Thank you very much, and good afternoon to everybody. Hydrogen, yes, it is a very promising subject nowadays. We all are discussing about hydrogen, decarbonization, many more things. We in steel business, we started producing not hydrogen, but this is a syngas from coal, that is coal gasification, where we produce 60% hydrogen and 30% carbon monoxide. 10% is other gases like nitrogen and methane. And we convert coal into gas, that is syngas, through Lurgi process of Germany. And we are utilizing this gas, this is called synthesis gas, to produce DRI, that is used for making steel through the electric arc furnaces. And with this route, we are in a position to reduce total carbon footprint from 2.5 ton per ton of CO2 to 1.85 ton per ton of steel making. So from 2.5 ton CO2, we brought it down to 1.8, 1.85. So this is 60% hydrogen syngas. Now we are working how to increase the hydrogen percentage in syngas to 75%. And hopefully we'll be successful very shortly, and we'll be doing about 72 to 75% hydrogen and balance about 22% or 23% of CO and nitrogen. So this will be used in the same retort or kiln, so that we can use the syngas, high hydrogen or very rich hydrogen syngas as a reductant in our furnaces. The other area, what we are working now, how to inject this syngas into blast furnaces, where we use coking coal and finally the coke, PCI coal and coke together. And the total carbon requirement is about 500 to 550 kg per ton of steel making. So we produce 8.2 million ton steel, and there's a substantial quantity of coal we are using through the coke route. And then finally, we thought that why not to go for the hydrogen. Now we are working perhaps first time in the country to produce hydrogen from coal. And this plant is under now a negotiation with some of the companies in Japan and also Australian company. We will be putting this plant how to convert hydrogen into coal into hydrogen. And this coal into hydrogen will be a path-breaking technology in this country. And hopefully, just a minute, please, just 1 second. Yes, please, sorry. So this will be a very path-breaking technology. We'll be converting coal, Indian high-ash coal, into hydrogen. And I don't know whether to call it a gray hydrogen or any other kind of hydrogen. And this hydrogen will be injecting in our blast furnaces and also in the electric arc furnaces. So this is what is on the table now. Hopefully within the next 2 years' time, this plant will be in operation. Now the other plant, what we are doing is to put up the IGCC. I mean, coal to syngas and syngas to integrated gas-based combined cycle power plant. So we are looking to convert one of the plant 250 megawatt, and we'll convert this plant into syngas. Now it is coal-based plant, and all of these boilers will be removed, and we'll put a turbine. And this turbine will be a 250 megawatt turbine, and we'll convert coal to gas and gas to power for our captive use. So you see today the Rankine cycle of 34% of the total efficiency when we burn coal into through boilers and to produce electricity. So through this process of syngas to IGCC route, we'll be in a position to achieve to combined cycle plant at least 58 to 60% of efficiency. So if you see that from 34 or 35% efficiency level going to 60% efficiency level, this is the technology what we are negotiating with GE and Siemens both, and hopefully both are in the same range from 58 to 60% efficiency level can be achieved. So we are working very seriously on this. As far as the hydrogen, green hydrogen is concerned or clean hydrogen is concerned, we started using hydrogen in 1995 through a water electrolysis process in the country. And perhaps we were the first or second plant in the country who were using hydrogen for the inert gas instead of nitrogen in our annealing furnaces. So now we are going in a bigger way. We are working that we will produce hydrogen out of coal, because India is blessed with 350 billion ton of coal, and the cost of hydrogen will be pretty low. Today we are producing syngas from coal, and we are getting at a level of about $4.5 to $5 per MMBTU. And if we have our own mines, then this can be brought down to say about $2 or $2.5 per MMBTU. If you see today the prices in Europe or in UK, the gas prices are unaffordable. The power prices are unaffordable. The power is at about 55 euro cents in Germany. Power is in UK is one pound per kilowatt hour. So that is 100 rupees, Indian rupees, 100 rupees per unit. Of course, India also, the power prices have gone up through the exchange. We have sold power at 20 rupees per unit a couple of days back in a peak load hours. But on and average, the situation is not very good even in Europe, because people are going to freeze if Russia doesn't help them and doesn't release the gas. So this is something, a very serious issue. So what I mean to say that we have to have a very holistic approach. We have to see that what suits to India. So in my view, the suitability is in India, we should convert coal into hydrogen, and we should use hydrogen in most of the heavy engineering industries. Secondly, the solar to clean power and then converting clean electricity into through the water electrolysis process into hydrogen. It is a little distant dream unless the country comes to one tariff, one country, one nation, or one tariff, one country policy. I mean, pan-India basis, the power cost has to be unified. Power cost has to be one power cost for the entire country. And the grid has to be one grid. And one grid means no wheeling charges, no any kind of other levies. Somebody produces power in western part of the country should be available in the eastern part, except the losses, but the line losses are there. I mean, that should be lost, otherwise they should not be in charge of any kind. The day Indian system gets mature to that level, then I think many more hydrogen plants based on clean energy or based on solar energy may come in the western part of the country, where the power factor is quite good, from 0.25 to 0.27. And most of the heavy engineering industries are located, heavy engineering industries are located in the eastern part of the country. And then either the hydrogen through the pipeline or the electricity through the grid can be transported in between the two zones, west and east zones. The another point here is I would also suggest Government of India that in future, whatever the new thermal power plants are coming, or government intend to put up the thermal power plant, I mean, these power plants should come on the pit head near the coal mines, and either through the syngas route or through the hydrogen route, the electricity should be produced, and not through the conventional Rankine cycle method. Now, coming back on automobiles, I think the hydrogen buses are plying in Europe for the last 20 years. It is not a new thing. And through the hydrogen fuel cell, yes, the development worldwide has taken place, and many more developments are taking place now. I think we have to divide into three areas. One, the commercial vehicles, the other is passenger vehicles, and in the metro cities or the bigger cities. And number three, the industrial use, hydrogen for the industrial use. So industrial use hydrogen, I already told you, making hydrogen or with a clean hydrogen or green hydrogen and then using the steel plants, it is a distant dream. It will take some time, maybe 25, 30 years time. But converting coal into hydrogen is an easy job. And hopefully within the next 2 to 3 years, Jindal Steel and Power will be in this particular technology demonstration drive. We have already shown to the country, and not to the country, to the whole world. We are the first plant in the world using syngas to produce DRI and DRI to steel. There is no other plant, even today, in the world who is producing coal to syngas and syngas to steel. So we are the only plant. Now, looking at our plant and efficiencies and everything with $4.5 per MMBTU, which is much lower cost than the natural gas cost today. The Government of India has taken an initiative that 100 million ton of coal will be gasified into syngas, and then syngas to methanol, syngas to ethanol, syngas to power, syngas to fertilizer, syngas to olefins, syngas to plastics, PVC. These products will be produced. We had a plan to put up a coal to liquid plant, that is CTL, and in fact we signed an MOU with Government of Odisha, and they allocated us Ramchandi mines also near Angul. But unfortunately, in 2014, these mines were cancelled. Honorable Supreme Court has cancelled all the mines, so that plant and project has been kept at hold. There were 2 plants coming in the country. One is by Jindal Steel and Power, and the other was from Tata Steel. So both were interested in putting up a CTM, and this is a large plant, 100,000 barrels plant per day. It is not a small plant; it's a very large plant. And unfortunately, because of non-availability of coal, this has happened. It is really a very painful area that a country who is having 350 billion ton of coal, we take out only 800 million ton coal in a year. So I think we should take out more. Maybe we should take out 2 billion or 3 billion ton coal per year and convert into gas, either hydrogen or syngas, or convert through coal bed methane or underground coal gasification. I mean, these are the technologies which are going to survive, sustain for a country like India. Depending entirely 100% on hydrogen, in my view, it is not a right thing. But yes, for technology demonstration to keep pace with the world, it is good for the country. We're a large country. It's good for us that we should do all kind of development so that we can produce green hydrogen through solar route. Otherwise, God has bestowed us the best of the best fossil fuels in the world, and that is 350 billion ton. We are the 3rd largest reserve of coal in the world, but unfortunately, we do not take out. We take out only 750 to 800 million ton, whereas today's requirement is 1.2 billion ton. Today, you are seeing there is a shortage of electricity everywhere in the world. Energy shortage. China is also facing energy shortage. Europe is also facing a energy shortage. So we have to see that in all this drive and in all this campaign, we should not lose our current growth, and we should not lose our current economy. You see, many times we see that we always curse that the power produced is through the coal, but can we afford 1 hour or 2 hours of power off or power cut today in our homes in India? I think no, because everybody feels that this power is coming from a very dirty product, and that is coal, and which is against the climate, and it is creating problem in terms of global warming and everything for climate change. But on the other side, we do not have any alternate today. We have to develop all those alternates, and we have to find out how to produce power through IGCC route, how to produce power, coal to syngas and syngas to power. I think that is the only solution. Coal to syngas to hydrogen. I think that is one more solution which I am putting in front of all these senior technocrats sitting here, debating here, and the panelists. Thank you very much.
Thank you. Thank you, Mr. Sharma. What we will do now is to
Anurag, Amrit, Anurag Pandey has joined from Reliance. So, Anurag, if you can switch on your video.
Hey, sorry, everyone. First of all, my apology. Got stuck with something, very pressing, so joined late. But I'll take a pause here, Amrit. Thank you.
Thanks, Anurag. Actually, I know what I'll do is I'll sort of cover some context so and can jump into the conversation. You've come in at the right moment to talk about the perspective from not just RIL but also from the ecosystem perspective. I think we want this discussion to be about that. One of the points that many of the panelists made was the importance of domestic manufacturing to drive down costs and to have India play an important role in the global supply chain for hydrogen. We also covered off the importance of linkages between different parts of the value chain. RIL, of course, is one of the few companies which has talked about a electrolyzer manufacturing plan. But do you want to come in on that and to talk about the importance of supply chain development? Let's start with that before I shoot questions.
Yeah, sorry. Excuse me. I do not know whether you are saying the supply chain from the supply chain point, the hydrogen supply chain point of view, or the supply chain of the components in various equipments of the technology to be, to be part of the hydrogen value chain.
Yeah, so both. One is, let's start with the hydrogen value chain first, and then sort of break it down from a production standpoint. What do you think could be the way electrolyzer manufacturing, for example, proceeds, right? And the same way on the fuel cell side, on the use case sides, both for stationary and mobile. And of course, storage, very important, because we'll probably need pipelines which can carry both gas and hydrogen as we're building it out.
Yeah. Thanks, Amrit. So, from the supply chain point of view, for transporting the hydrogen, obviously from the generation point to the, to the point where it will get consumed, as I'm sure that every panelist and the audience here understands that that's a kind of a holy grail, of the whole hydrogen value chain. The cost incurred in the supply chain, could be as high as or even higher than the cost of hydrogen production. So obviously, from a pricing point of view, hydrogen is a price available to the consumer. It becomes very important unless, obviously, if you can generate the hydrogen on site wherever it is getting consumed. And obviously, if you do that, then the whole angle of, providing, let's say, the primary energy vector, which could be electricity in case of the green hydrogen, that cost itself would go up because you are then talking about the grid. So either this way or that, where you are transporting either the gas, the hydrogen itself in various forms. That hydrogen could be in the liquid form or in the pure gas itself, or even the hydrogen carriers like ammonia, methanol, or many other ways of carrying that hydrogen. The supply chain is very critical, from our point of view. And for the overall hydrogen economy point of view, right? It doesn't matter if you produce it at less than $1 even, but if, let's say, to the consumer it comes at about $2 or $3 plus, then the economics completely changes. So from a long-term point of view, I would say supply chain is something which we as a country level has to very seriously look at. And obviously there is no one single solution which fits all the bill, right? So in the initial phases, it will be something obviously depending on the end. The form of the hydrogen, right? Whether you're going to use it for the mobility sector or for the industrial sector, the purity of hydrogen, there are various, elements one needs to, consider. And obviously, when you're talking about this, the storage is inbuilt into this in the supply chain, right? So how are we going to look at it? So maybe in the initial stages, when you're talking about, probably, few hundreds of, tons of hydrogen consumption. And again, when I'm saying in the early days, it is not really early days, even few hundreds of tons of hydrogen outside the industry, which does not use the hydrogen. That's a significant quantity of hydrogen, to be moved. But I'm sure, the gas-based economy has already looked into, so, the way you store, let's say, in the buffer of the, the pipelines, you can store a lot of, natural gas, right? So a similar strategy can also be thought about the hydrogen in the mid to long-term, solution. So hence, creating an infrastructure equivalent to what is there on the natural gas today would be, would be required going forward in the mid to long term. And I think we will have to think at a national level, we'll have to think that of strategy right from today, because we will be doing infrastructure investments. And as the Honorable Prime Minister has said, that the gas-based economy is something we are looking forward to, right, in the intermediate term. And we will have to think, how that investment can be then obviously utilized further when you have the hydrogen, hydrogen economy in place. So that's on the hydrogen supply chain part of it. From a transportation point of view, obviously there is a whole supply chain related, points, across the various elements of the hydrogen value chain, right? And whether it is the technology used for the production or, the technology used for the consumption of the hydrogen on the other end. And, many of those, elements in that value chain, we would be probably, let's say, we would have some internal capabilities, but we will have to also rely on the external markets, right? And it will be important to, let's say, from a long-term point of view, we will have to make those arrangements. Again, purely I'm talking about from an India point of view. And right now it will be quite difficult which technology would be better suited. So I would say the options needs to be in such a way that we consider all the technology options, particularly on the electrolyzer front. Obviously, you have the legacy technologies like the alkaline, relatively more mature technology, PEM, but then there are anionic and solid oxides are also coming up, and obviously the solid oxide having a higher efficiency also makes the, let's say, the economic viability more a better case for the hydrogen in there. So all of those technologies use different building blocks, building materials. Obviously there are commonalities on the balance of plant, all the peripheria which goes around the heart of the technology, where I feel that Indian industry has relatively let's say large supply chain, but on the main, the heart of the technology, we will have to look at that closely, how much of that we can do internally and how much we would rely on the trade partnership. So that's on the supply chain part of, the technology itself. But at the same time, in the whole context, we should not forget about the other technologies, like the low carbon technologies, towards the hydrogen, right? Because ultimately we will have to realize that to produce that green hydrogen, ultimately you have to generate the green electricity. And I have been contemplating, and what I think is about RE 2.0, right? So far the story has been the renewable energy for the electricity. The story is going beyond now electricity, if you are talking about the green hydrogen. So we will have to look at that entire supply chain, at a much, much larger scale, right? Just from the green, hydrogen point of view. And I feel, green hydrogen alone would not be able to suffice the need. If you are really looking at the Atmanirbharta, what we are talking about, we will have to look at, the other, probably sources of electricity, which could be renewable, but not just in the conventional way, what we think of solar and wind. But at the same time, the low carbon based or probably carbon neutral based technology as well. So I mean, in a way, we are going to rethink, redesign. The whole fabric is going to readjust to a new way of, moving energy across the economic activities, and it requires, very deep and rethinking of how the economy runs, right? Whether it runs, the hydrogen demand in the energy, the conventional energy, what we're talking about for the industry, or the electricity, or even for the feedstock. The potential is really, really very high, and hydrogen not just acts as a decarbonization media, but also the new energy growth for us, right? It's a new growth engine, for the economy. Supply chain on either side is very critical, and we will have to rethink, redesign, and hence a national level roadmap, a seriously thought through national roadmap is very critical, so that we all as a participant, whether from industry or various stakeholder, we know exactly what path we are looking at. The great thing is, like our honorable, Prime Minister has already declared the aspiration to become the Atmanirbhar in terms of the, energy by 2047. And if you look at that aspiration, I'm sure we can design something which takes India to that, ultimate moment where we can, be closer to the Atmanirbharta in terms of this, energy security. So I'll take a pause there, Amrit. Thanks.
Thanks, Anurag. What we'll do is, I know we are short on time, but we'll shoot at least one questions to all the panelists to cover off some of the areas we spoke about. And I would actually want to ask very specifically, Mr. Sharma, to begin with, the importance of carbon markets. I know we've touched upon that in the earlier discussion. Do you think implementing carbon pricing on priority will help to accelerate decarbonization in steel, with hydrogen obviously playing an important role, including adoption of the technologies you mentioned, using syngas from coal gasification technologies. And if the answer is yes, what is the timeline within which you'd like to see that clarity? Is it 6 months, 12, 18, 24? Over to you, Mr. Sharma. Mr. Sharma, if you could comment on the video and unmute yourself. Okay, while we wait for Mr. Sharma to come back, let me move on to talk about something else. Jitendra, what in your view is a possible way for public and private sectors to work together? You and Toyota have obviously been working very closely with the government for almost a decade. You've also been collaborating with the private sector. What is an important structural change we need to make this time round to make sure implementation of the roadmap, once it's done, hopefully that will come through soon, implementation happens on a mission critical basis, the way it is happening in other parts of the world? Is it a public-private partnership task force, or is it an empowered body which does clearances for commercial projects? What do you think is required in the next 12 to 18 months?
Yeah, Amrit, I think that already some steps have started in that direction. The most important thing is that different industries need to come together. Different industries means it is required, like Reliance, who is manufacturing the gas. There are the people who are going to take care of the storage and transportation. There are the people like us who are going to give the fuel cell stack and different policy meetings. So all these stakeholders need to come under one umbrella. Then only it is possible to materialize or give the execution of this roadmap. If we work again in the separately, then it will isolation. It will not be possible to implement this roadmap, and that we have learned, I think, well in last 10 years. So from that point of view, I think other country has also started in that direction, and they also setting up such kind of consortium. And in India also there is a thinking that which we came to know, like under CII membership, that such kind of consortium is under consideration. So it's important that we set up such consortium and make not like running some 1 or 2 pilots, or that will not bring the commercialization. We really need to make the proof of concept. Means that as we need to use it widely. So we can select pilot in one area, and there we have to make sure that hydrogen is produced in the effective cost. We have to make sure that we use it widely enough so that we can make it commercialization kind of project. So I don't think that it is a time that we start 1 or 2 pilot and just be happy that something has started. I don't think that we can move to commercialization in that way. We nearly need to make the proof of concept. And as I told again, technology is available. It's only matter of initiating the real, bringing the funding. Of course, initially it may not be profitable, but yes, as we improve the scale and as we do more and more R&D and more make in India, it will be possible to make it commercially viable. So that is what I think it is required in coming time to make consortium and everybody work together in this direction.
Thank you, Mr. Goyal, for that. Mr. DMR Panda, if I could ask you to come in and weigh in on what would you like to see again in the next 12 to 18 months? What actions would you like to see from the ecosystem on making sure at least 4 or 5 of these large projects come alive? And again, please respond as somebody who's deeply invested in the hydrogen ecosystem, not just at NTPC, but you've seen this closely, and you've seen the hydrogen valleys, for example, in Europe come about. We don't have a national plan for hydrogen valleys right now. So what's your view?
I'll say that at least one of such projects from each area, say green mobility, one, blending, one, green steel, one, petrochemical greening way one. At least we must have one of such pilot projects keep on running, and they should start within another 18 months, which I find it is difficult. That is why I would like, I say that I like to see that it is on. So in India, we do not have any project for blending. We do not have any project on mobility. So that is why we must have this experience. And once these are on, then I can decide what is really good for India. Otherwise, it is just reading something and trying to ape something and not really knowing is it going to help us or not. So that is what I would like to see.
Thank you, Mr. Panda. I would ask Anurag to come in next. And the question is, and this is deliberately posed at you, Anurag, because Reliance can move very quickly on its own, and the funding discussion is probably one that you can answer easily, but I won't put you on the spot. I would like you to respond. For India to move forward, what is the quantum of investment that will be required to make the ecosystem come alive? So this is obviously beyond just what the private sector or a single player would do. What sort of monies are we talking about? And this is a funding. It is a funding question, but really from an ecosystem standpoint, what sort of quantum of funding should the government be looking at to make an ecosystem come about? Because otherwise, as I said, we will be repeating the design follies of the last 10 years, right? It will be a great document, but it will never be implemented if we don't talk about adequate resourcing for it. So how much do you think as India, as a nation, what quantum of investments are we talking about?
Well, my guess would be as good as anyone here. But, we are talking about really large number. I was just thinking about, other day, even to reach our 450 gigawatt, RE plant itself, I think it would mean about $200 billion investment, right? So if you are talking about the green hydrogen alone itself, right? I mean, the primary electricity, investment on the infrastructure would be, something on that ballpark. Obviously, that number is based on, certain assumptions. By the time we reach there, we can expect the cost to change. Even, about 100 gigawatt equivalent of electrolysis, let's say, if we plan, right? We are talking about something like $25 billion of investments at minimum, right? And that's just on the probably on the electrolyzer front. Then there's a whole infrastructures. Right? I don't think we have even worked out even probably a ballpark number on what are we looking at the transitional investments, right? I mean, the Global Hydrogen Council puts at numbers something in the 1.2 trillions onwards, and that number keeps changing, right? That number keeps changing, with the aspiration keeps changing, because the view keeps changing. We have just got started on this, right? I mean, the possibilities are enormous, and Dr. Malhotra is here, one of the best authority on this. He can speak hours and hours on this, what it can mean to India, and, what we can do in terms of. So I think, it's a little difficult question, but what we can say, we are looking at, hundreds of $billions of investments, even in this decade, right? And let's not look at that just investments, which would be, which will not create further economic revenue for us. It will create this, new high-tech, job, new high-tech industries, and this will bring back to the economy in multifolds, right? There are estimates we lose about 200 odd $200 billion in terms of the impact of the, the emissions on the economic activities itself. So now, if you're looking at that, loss in the productivity and the economic activities because of the climate change, right? These investments are not really high investment, right? Because we are investing in life, we are investing in future. And, so in a way, that investment is actually intangible, benefits of that investment could be multifold. I mean, there's no point of, having economy running if you and I are not going to be there, if you are flooded and if you have the droughts there, right? So I think there is a very different way of looking at all of this. And we have just scratched the surface. I'm sure there are better people who would articulate this much better than what I am, attempting to do here. But we will have to look at this very differently. Just on the monetary front, we are just getting started, and I think investments of that tune of hundreds of $billions within a decade would be needed. The good thing is, like, all the investors, as you know, all the sovereign funds are very keenly looking at that, and the investments do not seem to be that much of a problem. But yes, it will remain a challenge for a country like us. But I think people are looking at it, and the shareholders, the common people, will push towards this kind of transition. And so, Amrit, sorry, I do not have an exact answer for it, but I hope I have given the feel for the kind of investments and the kind of narrative we are looking at going forward in the future.
Thank you. Sorry about that. Thank you, Anurag. That's exactly what we wanted, a sense of scale from resourcing standpoint. And again, I will, staying with the same theme, we don't have an innovation fund of that quantum. But if we have to move towards that, we have to learn from markets like or regions like Norway, which have a large innovation budget, or Europe. So Sturle, if I can ask you to come in on that, can India learn from Europe and other parts? Because really this is about innovation funding at an ecosystem level. What do you think? And you've been in India for long enough to understand what we can do, or what are the immediate challenges. What do you think can we realistically achieve in the next 3 years, right? Next year, we will be, presidency of the G20. India will have the presidency of the G20. We should be able to stand and talk about, from an energy leadership standpoint, on the funding discussion. So can you please come in and give your views there?
Sure. First of all, I would say that I agree with Pandey when he said that let us not think about really the number, because it's changing all the time. And we can't really afford not to act and go forward. India is extremely attractive country for investors, and particularly in the energy market, because of the growth prospect. And the Norwegian Environmental Fund, the Norfund, has put aside 10 billion to go into this energy market for renewable. And I see that there is almost every day from the financial news, new funds that is coming forward as well. But I think what is important to make these people convinced that they should go in, this is the good timing. The government need to set these targets. I think that has been discussed and brought up by some of the other panelists as well. We need to know that the government have a goal of 10,000 buses, 100,000 buses, 2,000 filling stations, and so forth. And in each of the sector, either it's in the industry, or it is in the maritime, or it's in train or transportation, all these sectors, there has to be targets. And these targets can be adjusted upwards as we see how things are moving forward. Because when you set these targets, you would see where is the bottlenecks and where you need to kind of open up and find partners or technology that can help it along. And I also think that it is important that we have talked now about the government, we have talked about the privates to bring them on board, but also R&D institutions are extremely important to bring down the cost. And we are talking about pilot projects. We don't need one in each. We need to actually several in every state, because there is such a need to in so many areas, and we need to make sure that each state is also have this knowledge. So to set up center of excellence in hydrogen in the different universities in all over the country, I think that should also be put on the agenda as well. But when it's coming to funding, I'm not concerned. At least I see that they just want to understand where the government is going, and that the government is committed further to develop this plan, because that can reduce the risk. So funding will come forward, and you can see how EU, Eureka program, and all the others, I'm sure that you're all familiar with them. They will be global. They will not be focusing on Europe or any other countries. They would go where it is attractive and where they see growth. India is no better choice.
Thank you, Sturle. I know we are 5 minutes over, but Dr. Malhotra, if I can pose a question to you before we wrap up. You have obviously been part of the previous 10 years planning on how we sort of commercialize hydrogen. What extent do you think we should go from a planning and capacity building standpoint, public private together? What is the mechanism that we need to create in the next 12 months to make sure the Prime Minister's vision and the ambitions that we are talking to are met? What is missing? Because obviously more of the same will not get us ahead. So over to you.
No, I don't think, I think now we are in the right kind of atmosphere. As I said in the beginning also, the ecosystem is fairly favorable because of after this pandemic, people have started talking. International Energy Agency has said there should be investments in clean energy. There should not be investments in a refining sector, although our refining sector, which I belong to, and Anurag also come from the same, group also. And they feel that India will need more of liquid fuels and in time to come, and it will continue to grow. So this is a dilemma which which is being faced. But I'm sure the fossil fuel investments will dry up, and there is no dearth of investments or investors who are willing to put in money in renewables. The kind of growth we have seen in the stock markets also of the clean energy companies, I think the system is now very well tuned. 10 years back, I had started talking about hydrogen when I was heading the Indian Oil's R&D, and that time my management also, with due regards to them, they said, you are talking about hydrogen, it is a futuristic fuel. So I said the R&D has to prepare for the future. That's my job. So they said, okay, you do R&D jobs, we don't talk about commercial. I spoke to my director of refineries. One of the company wanted to get hydrogen for telecom towers, which were and one of the British company was ready with the fuel cells for telecom towers. And they said, okay, give us hydrogen from your refinery, because as you know, we are the largest producers of hydrogen and consumers as well. So they said, give us at whatever price you produce, we will clean up, we will, and you charge your profit to an extent. We will bottle up and supply to the telecom towers. Our director of refineries, my colleague on the board, he said that no, this is very small business for us, So that's how the story goes back. But now things have changed. Now whether it is Indian Oil, whether it is Reliance, whether it is anybody else, everybody is talking about hydrogen. Everybody wants to get into hydrogen. So I think we are now in the right, ecosystem, as you may say. The investors are willing to put in money. There is no dearth of investors who will put in money in clean energy, including hydrogen. The international agencies like IEA or everybody is saying, let's get on to, and nobody wants to miss this bus. I see every stakeholder wants to, I see different ministries also in the government, whether you talk of the coal ministry, they have made a committee where they have asked me to chair a group on how we can produce from coal. There is MNRE which is working, the Petroleum ministry is working. Every ministry is keen to push hydrogen. So it's bound to, and it has come from the top, the Prime Minister on 15th of August. It makes great sense if the Prime Minister says from the Red Fort on Independence Day that we have to have a hydrogen vision. I think it is bound to happen. So now all of us have to come together, and everybody's Reliance has already committed a lot of money. Indian Oil, I know my previous organization, I keep on talking to them. They're very keen and very want to be very aggressive in that. So I think and NTPC also, while they are thermal power, the name says National Thermal Power Corporation, Indian Oil says Indian Oil Corporation, but everybody wants to turn green and wants to produce green hydrogen. But as I said in the beginning, let us walk through the route of grey, brown, if not, then at least the blue hydrogen, and then to green, because infrastructure building up will take time. Let us not wait for green hydrogen to be available, because renewables can be used for power sector. You want to use them in electric vehicles, then you want to also produce hydrogen. So I think let's start with blue hydrogen. We had, when I was at Indian Oil, we had developed a process where pilot plant is there. Now they are building up a semi-commercial unit on petcoke, coal and biomass co-gasification. Reliance is got a lot of gasification units. Mr. Sharma from Jindal was talking about coal gasification, syngas, and how the efficiencies, even if the efficiencies go up, whether if you use in fuel cells, there also the efficiencies go up. Then you can reduce your imports of energy, So, and then you will also reduce the carbon emissions. So let us take a holistic view of the whole thing and not say that tomorrow itself or today itself I want to go to green hydrogen. We will go there, but let's walk through blue. And then, as somebody I was talking to in a refinery, private refiner, the CEO I was talking to 2 days earlier, and he was saying, I'm willing to sign up a contract if somebody can give me green hydrogen for $1.5. I'm willing to buy all that and shut down my hydrogen generation units in the refinery. But it doesn't come. But it is, and Mr. Sharma was saying, no, the grid transmission costs, etc. Even NTPC announced in one of the, Mr. Panda has left. He had said that NTPC will give, the green hydrogen in $1 per kg. Of course, Mr. Ambani has said that he will give $1 per kg in 1 decade. I believe Mr. Ambani, when he says something, he will do it. NTPC was saying we can give soon. Then my refiners called me up and they said, okay, you get us a contract, from your federation, because I had the Federation of Petroleum. Some of the refiners said, okay, if somebody can give us a $2 of green hydrogen, $2 per kg, we are willing to sign upfront for any quantity if they can give. So nothing is available at that point of time, at this point of time. So let us be realistic and build up the infrastructure so that ultimately, if you have cheap green hydrogen available, let us not be finding ourselves that there are no takers. There is no way how to transport it, because Anurag also said that the cost of transportation and storage is even more than the cost of producing hydrogen. And electricity also, if you have to transmit and then losses over there, etc., and tariffs structure, you don't have a power tariff structure, which is one. So I think these are some of the issues which we'll need to address in this country. But having said that, the ecosystem is very conducive for moving towards hydrogen economy, and I am sure we will move towards that. But we'll have a lot of, some steps how to overcome, some difficulties we'll have, some challenges we'll have. Okay.
Thank you, Dr. Malhotra. I think what you said, you used a word called a holistic framework and view, right? Holistic means all parts of the value chain, both demand as well as supply side, as well as decision making. I mean, we can't have 5 subcommittees on hydrogen by 5 ministries when they all need to sort of connect with each other.
Let us have a coordinated approach. Yes, that's right. You said it. But I think this is being monitored at Prime Minister level also, and something is going to really happen the good way for this country. Let us have faith in, but everybody has to contribute their bit.
Yes. Hopefully, this discussion has also brought about some practical challenges, sort of the quantum of investments, the requirement for standards, etc., to the fore, because there are 2 levels, right? One is planning and design, the other is implementation. Unless we have our implementation game plan ready and implementation teams ready, investors will not come in with just a plan. With that, let me thank all the panelists. It's been 15 minutes over. I hand over to my co-moderator, Praveen. Praveen, if you want to cover off before we close.
Thank you, Amrit. And it was a very absorbing session. And I, on what we can say on the more on the delegate side, listening to stalwarts who is going to make a difference in the hydrogen economy going forward. And definitely, as we have seen in the fintech world, we are moving in a very brisk pace. And obviously, Reliance Jio has a lot to contribute in that. I think with now Reliance Industries looking at this sector in a big way, and they are looking at all stakeholders at the same time and all the ecosystem at the same time. And definitely, as Mukesh Ambani talked about bringing it to $1, I think definitely it will make a mark. And let us all be optimistic. And as our main theme also talks about moving in the big league, we are what we can say trying to move in the big league. Let me thank Mr. Amrit Singh, our moderator, Senior Managing Director, FTI Consulting, our panelist, Dr. R.K. Malhotra, Director General, Federation of Indian Petroleum Industry. He is always very lucid, and he is also what we can say, it says the right thing, so that we know what is the gap, and accordingly those gaps needs to be filled up rather than giving lofty ideas. We had Mr. Vidya Rattan Sharma, MD Jindal Steel and Power, and he gave a very holistic view and a complete view of the what we can say the steel industry and what plans they do have for the hydrogen. And Sturle, Harald, Pedersen, Chairman Greenstat. So he gave an overall global perspective of how things are. And DMR Panda was talking about he's busy with NTPC's plan. There are a lot of RFPs that he has floated. There are a lot of expression of interest that he has done. So things are moving in that direction in the coal sector and the energy sector. Anurag Pandey, though he was a bit late, but he made it up with the plans of what the company is doing and what the entire ecosystem needs to do. Jitendra Goyal, many thank you, sir. GM R&D, Toyota Kirloskar Motor. I believe the day is not far off when we will have hydrogen as a fuel. In the same way, like we will have the what we can say flex engines, so that depending upon what fuel and at what price you get, and depending upon what you want to choose, you can do that. And Dr. Klaus, Brun, Director R&D, Elliott Group. So we had a very interesting session. A big clap for all the people who made this. Let me also take 2 minutes more, and let me also give a vote of thanks for this 2-day summit that we had. And ladies and gentlemen, now as we have reached the fag end of the NextGen Chemical and Petrochemical Summit 2021, our main theme was moving in the big league. I would like to acknowledge the presence of all dignitaries, speakers, and delegates present with us during the 2-day-long deliberations. For the last 2 days, the event was witnessed over 11 sessions on policy, digitalization, CMSR, petrochemicals, specialty chemicals, agrochemicals, sustainability, pharma, NextGen, and hydrogen, addressed by 73 speakers and 12 presentations that covered a lot of topical issues concerning the chemical, petrochemical, pharmaceutical, energy, digitalization, and much more. Apart from this, 3,400 plus delegate registrations by stakeholders from various verticals of the industry and academia. We have also received an overwhelming response in the form of calls, emails, and WhatsApp from across the country. The maiden edition of NextGen Chemicals and Petrochemical Summit was appropriately themed as moving in the big league, and India will move in the big league. And that is what that statement will come. And I think all stakeholders in India are working to achieve this. And I think we are all dreaming big, and the day is not far off. The 2-day-long virtual summit cum exhibition hosted thought leaders, policymakers, and stakeholders across the theme. The idea behind NextGen Chemicals and Petrochemical Summit by Indian Chemical News was to provide a premium forum for the high-quality deliberations, apart from offering insights from stalwarts of the chemical and petrochemical industry. It provided ample networking opportunities with industry experts and solution providers. All the deliberations that we have will be put on our Indian Chemical News website, both in the text format as well as video format. So anybody who wants to can have a what we can say go to it, and we will put it on in a digital format, in a digital archive format, so that it will be there for a year or so. I would like to thank all my speakers, 73 odd speakers, 3,400 delegates, and our sponsors, Platinum Partners, Aspentech, Trend Miner, Elliott Group, and Tri-Diagonal Solutions, our gold partners, GPC, Ingenero, Dur, Evonik, Rico, Premier Tech, Agilent Technologies, and Honeywell, our associate partners, Make Money Finecam, Huntsman, Solvay, Aarti Industries, Sargent India, Godavari Biorefineries, and Carbenio, and our association partners, AMAI, PMFAI, and CCFI. I would also like to give a big thank. I'm just at the front end, but my team, which is the team ICN, has done a wonderful job at the back end, and they have spent a lot of days and nights to make this platform, to make this ICN NextGen Chemicals and Petrochemical Summit a huge success. So a big round of applause for all the back end people who supported it. So with this, I would like to thank once again hydrogen being the last session, but the kind of zeal, the kind of support, and the kind of energy with which all speakers were speaking, I think it made my day. So this is Praveen Prashant, editor, Indian Chemical News, signing off. Thank you and goodbye. Stay safe, stay healthy, and happy Navratri. Dhanyavad.